this is Mr. Manley, and in this video I'm gonna do a little work with exponents. So this will be a review for anybody who's had algebra or beyond. And what I would recommend that you do, this is gonna be a pretty quick video, right? I'm just gonna take the problems that are here on the screen, and one by one I'm gonna work through them. Maybe I'll talk a little bit about some properties or laws, or maybe not, we'll see. But before I do that, what I would recommend is you just, if you think, I know this, I know how to use exponents, well, then just really quickly go ahead and write these down before continuing and simplify each of them. There are 4 expressions here, and just simplify each of the 4 and see what you get. And then go ahead and continue with the video and see how it compares to what I do. With that said, let's begin with the first expression here in the upper left. And I'm going to notice that I am multiplying. I'm multiplying this in parentheses times this in parentheses. And that's a negative times a negative. So that's going to be a positive. I have taken into account negative times negative is positive. I will not need to write any more negatives. I look and see that I have a number, a 2 and a 3. And I can multiply 2 times 3. Get 6. I see that I have an x and an x. I'm multiplying. Now remember, when we multiply and we have a common base, we add the exponent. Now I have x to the 5th. And then I see the y. I see a y squared and a y. Add the exponents and I get y to the 3rd. What would be an error someone might make here? They might say, well, I'm multiplying, and then they might multiply the exponents and say 3 times 2 is 6. But what's happening is I'm saying x cubed times x squared, and then if I think about that x cubed as x times x times x, and I think about the x squared as x times x, I've got 5 x's, and that's x to the 5th, which is what I did there. Let's move on to the next one. I will take the one on the right here. I can't do 3 times 2, right? Because that's an order of operations issue. A 3 and a 2, but I can't do multiplication because order of operations says that I have to do the parentheses and the exponents before I do the multiplication. I cannot do 3 times 2 yet. What do I have first? Parentheses. I want to simplify these parentheses here. Can't do anything with 3t squared, but I've got this exponent here. What does that get me? Gets me 3 to the 3rd and 2 to the 6th. Here I am multiplying the exponents. When I do a power to a power, I multiply the exponents. And then moving on to the next parentheses, I get 2 squared, which is 4, and then t to the 8th. That's from 4 times 2 is 8. Okay, 3 to the 3rd, That's 27 times 4. Look what I'm going to do here. I need to do 27 times 4. Maybe you'll pull out a calculator, right? But let's try a nifty little trick here and say, well, that's 25 plus 2 times 4. So 4 times 25 is 100. 4 times 2 is 8. So I get 108. Of course, you could stack them on top of each other and use that algorithm, but I find that splitting it up like that, that's something I could have done in my head maybe a little bit more easily than stacking them in my head. T to the 6th times t to the 8th, we add the exponents as we saw in the previous expression, and we get t to the 14th. So there's 2 for you to compare if you did them preemptively. And let's move down to the bottom left. I'm going to see if I can be pretty fluid in distributing this 5x cubed to here, to here, to here, and just keep distributing the 5x cubed, right? That'll give me 25x to the 6th. Remember, add the exponents. X cubed times x cubed is x to the 6th. Do not multiply the exponents. 5 times negative 6, that'll be minus 30. And then x to the 3rd times x squared will give me x to the 5th. Plus 15, x to the 4th, minus 5x cubed. And finally, this last one over here, we've got some negative exponents. And we've got to work the PEMDAS here. Parentheses and exponents before I do any multiplication. There are a couple of ways we could proceed here. I'm going to go ahead and say I've got a to the negative 6th over b to the negative 3rd. Times b to the negative 2nd over a to the negative 2nd. Again, a couple of ways to proceed from here. I'm going to do the negative exponents first. So I can rewrite the first factor as b to the 3rd over a to the 6th. See how I worked with the negative exponents? This might be interesting to look at. If I had, let's just say I had 1 over x to the negative 2. One way I could look at that is that is 1 over x squared. And that would be a way to deal with the negative exponent. Well, 1 over x squared, and this is not the way I would do it. I'm just showing you a way to think about it, or that this is a way to approach it. 1 divided by 1 over x squared. See that? So that, of course, that fraction bar is that division. Well, what do we do with division? 1 divided by 1 over x squared is 1 times the reciprocal. 1 times x squared, x squared. So that would be a way to proceed with that. Another way to proceed with it would be to simply say 1 over x to the negative 2 is equal to x squared. The negative The negative means reciprocal, right? That negative exponent means reciprocal. And in both cases I did reciprocal, right? But I just did it in a different way. Here I reciprocated within the denominator. Here I reciprocated within the whole fraction. And they're both correct, right? Or they're both the same. They end up in the same place. They both end up at x squared. Obviously, the second way seems to be a more efficient way of thinking about it. And that's what I did back up here. As I took and reciprocated, I reciprocated within the whole fraction. Again, I mean, I could look at this and say, well, that's 1 over a to the 6th over 1 over b cubed. I could think about it like that. And I'm going to end up at the same place eventually. I think it's that you do need to see both ways and understand how they're related. Okay. So where we're at, where are we at? We're here. With this, I'm going to reciprocate within the whole fraction, right? So I'm going to say it's a squared over b squared. Right? I can rearrange this. I could probably just go straight to simplifying it. But just understand that these fractions being multiplied this way, well, that's equivalent to I can take out that multiplication symbol, right? I can just push it all together. And then I can notice, I can notice it back here. But maybe I notice even more that, well, I've got these b's that I can group together. And you can rearrange these. That's the commutative property, right? I could rearrange this and say, well, that's b cubed a squared over b squared a to the 6th. Again, not to do it this way, but understanding, being able to follow it if I do it that way, you understand why I'm allowed to do it that way. And maybe being open to doing it and taking an extra step to make sure that we keep things straight, right? That could be a possibility. Let's simplify this. B squared, b cubed, and that leaves me a b in the numerator. And then a squared with a to the 6th leaves me that. You know, and how did I think about that? There's a property of exponents, right? That if I have a to the m over a to the n, that's equal to a to the m minus n. I can subtract the exponents. And I can subtract them either way. I could also say a to the m over a to the n is equal to 1 over a to the m minus m. Look at both of those and see. Both of those are allowed. Understand why. Now, I actually I don't even think I thought about those properties here. I think really on some level, in my mind, I just saw a squared, and that's an a times a, and a to the 6th, that's 6 a's. And I said, well, I'm going to cancel 2 of these a's with 2 of these, and I'm going to be left with 4 of them. That's probably what was happening in my mind, maybe. And we've got that simplified. So b over a to the 4th. Can even see very advanced students, even up through calculus in college, making errors with the properties of exponents, probably careless, maybe through some fundamental misunderstanding, and always coming back and being careful to be able to apply PEMDAS. And if you're having trouble applying PEMDAS and if that's getting noted in your work, you've got to go back and review that. You really can't move forward in mathematics without having mastered that fundamental. And that applies to anything, not just mathematics. It can sometimes be far advanced in something and not realize, or just set to the side some basic fundamental that you're missing. And it's hard to go back and correct that. But I do encourage you to do that, not just in mathematics, but in anything. So that's my review of exponents for today.